Assalamu alaikum students. How are you all? Hope you all are safe and healthy at your home. Let's continue our acids and bases session 2. Before that we recall some basics about what is an indicator. What are indicators? The substances which indicate a change in color when some other substance is added to them are known as indicators. So now here you are seeing some of the examples of indicators. They are petals of hibiscus. Here in this picture you are seeing a first picture, that is a hibiscus flower. In that you are seeing red colored part. This red colored part is called as petal. With this we can make a red colored. Next we are having another flower, that is a oleander flower. With the petals of this also we can make these indicators. What other indicators are there other than petals of hibiscus and oleander? We are also having beetroot, mango leaves, turmeric. Already you have did experiment with turmeric. So these are natural indicators. Next, children, you are seeing Henry Henry Cavendish is an Italian scientist who discovered a colorless gas called hydrogen. This colorless gas catches fire with a sound. This colorless gas is hydrogen. So you should remember who discovered hydrogen. Is Henry Cavendish. Next, we talk about pickles. Why pickles are stored or preserved in gas or porcelain or plastic containers? Why don't we use other materials? Now we see the inner sides of vessels made up of brass and copper coated. When some substances are kept in a copper container for a long time, then a blue-green layer is formed in the inner walls of the container. Here, copper reacts with the acids present in the substances and forms a compound, that is a blue-green colored compound. To avoid this reaction, the inner walls of these vessels are coated with tin. So now we are preserving our pickles in tin coated vessels. Now then we talk about acid rains. Children, what do you know about acid rains? What are acid rains? Now we see. These acid rains are the combination of carbonic acid and nitric acid with rainwater. These acid rains causes damage to our buildings, monuments like Taj Mahal, and to our skin also it affects. Industrial waste gases contain sulfur dioxide, nitrogen oxide, carbon dioxide. When they get mixed with moisture, they change to acids. Acid rains are also witnessed in our state in Visakhapatnam district. Why acid rains occur in Visakhapatnam district? Can you? Because it is so much industrialized, like you are seeing in this picture. More industries are there the poisonous gases are emitting out of that industries, and they are reacting with the gases present in the atmosphere and cause children. Have you observed a magician or a juggler cuts a lemon and blood flows out of this lemon? What happens? Why the blood is coming out of that lemon. What happened to it? Now we see. Can you believe that really blood comes out of this lemon? So what is the reason behind it? Now we see. Actually, he uses a knife dipped in methyl orange or hibiscus solution to cut this lemon. When methyl orange is mixed with citric acid, that is lemon juice, it turns into red color, but it is not blood. In many of our places, we find people doing this kind of magic. So it is the acids that is doing this magic. Now again we recall which substances are in basic nature. The substances which are soapy or slippery to touch, they are said to be basic in nature, like lime water, glass cleaners, soaps, milk of magnesium, etc. And which substances are said to be acidic in nature? The substances which give a burning sensation, acidic in nature, like substances like vinegar, lemon, orange, stale cheese, battered milk, apples, tea, olive oil, fats, grapes, palm oil, amla, urine, all these consist acids. These substances are said to be acidic in nature. So we continue. Let us perform an activity. Take a long magnesium ribbon. Use a sandpaper to rub and clean the ribbon. Hold the ribbon using a pair of tongs. Burn the ribbon using a spirit lamp or a burner. Collect the white ash in the watch glass. Take some water in beaker. Dissolve white ash in it. Now test this solution by dropping the blue and red litmus papers. Observe the changes in the color of litmus papers. In this activity, we observe that the red coated litmus paper changes to blue when it touches the solution, whereas the blue colored litmus paper is unchanged. Finally, we learned that the oxides of magnesium, when dissolved in water, form magnesium hydroxide. This is the formula. Similarly, oxides of potassium and sodium, when dissolved in water, form potassium hydroxide and sodium hydroxide. All these are basic in nature. They would be soapy to touch. Let us perform another activity. Take a retort stand on a table, adjust and fix a test tube on horizontal rod. Take about 10 ml of dilute HCl in a test tube. Now add a few pieces of zinc granules in it. Observe the surface of zinc granules. Insert one end of delivery tube into the test tube through a cork and insert the other end of the delivery tube into a glass tub. Fill the glass tub with soap water. Now the gas evolved from the test tube passes through the delivery tube into the soap water. At this time, bring a lighted candle near the gas-filled bubbles in the tub. Observe the reactions. Be careful while handling this. In this activity, we observe that a colorless and odorless gas comes out of the delivery tube. Bubbles are formed in the soap solution. The gas evolved burns with a pop sound. Since the gas evolved from the tub gives pop sound near the burning candle, it is confirmed to be hydrogen gas produced by the zinc granules and diluted hydrochloric solution. Finally, this activity shows us that hydrogen evolves when an acid reacts with a metal.